From the precise CNC machining of titanium to intense plasma welding, the massive titanium forging inches toward the testing station. Meanwhile, high-density silicon wafers are...
The large titanium alloy forgings are stacked in this automated vertical storage carousel, each tagged with an RF.
This marks the end of the shared raw material phase. The titanium requires macro-scale stabilization, the silicon, micro-scale atmospheric processing.
As the head nozzle forging moves to machining, the camera follows the high-speed transit of DSP chips. This
Temperature profile stable at 900 Celsius. Atmosphere is nominal.
Confirmed. Proceed with vacuum seal.
Laser scan complete, zero deviation detected.
Hydraulic clamps secured. We are green for machining.
Smaller, pre-machined internal titanium rings are loaded into the PVD chamber for a specialized ceramic thermal.
Inside the nitrogen-filled reflow oven, the PCBs undergo process B, precisely controlled temperature.
These sensors are crucial for feeding real-time positional and thermal data back to the flight control system, ensuring precise control and preventing overheating.
The robotic system injects specialized high-temperature lubricant into the hinge mechanisms.
We are initiating the pressure sequence now. Monitor sensor array Delta.
Roger that. All parameters nominal.
The specialized ultraviolet system illuminates the hydraulic fittings, searching for traces of fluorescent dye which indicate a
A high-resolution 3D scanner performs a final dimensional inspection of the nozzle assembly, projecting a dense grid of layers.
A robotic arm affixes the labels, ensuring traceable documentation. Process A is now
The spot welds look consistent across the rail.
Confirmed. We are ready for Process B integration.
The specialized data bus connectors are robotically mated, establishing the high-speed communication network. The system runs full control loops, verifying the real-time responsiveness of the DSP chips and the accuracy of the control algorithms. A simulated failure is introduced into one unit, and the other unit instantly takes over control without any disruption to the simulated nozzle movement. Check the alignment pins on the flange.
Looks good. Tolerances are within spec.
Confirmed. We are ready for the nozzle attachment.
All personnel, clear the stand immediately.
Blast barriers engaged. FCS diagnostic complete. We are go for ignition.
The titanium surfaces are showing expected cooling patterns.
Confirmed. No critical hotspots detected on the vectoring assembly.
Thrust vectoring nozzle clear. Guided in slowly.
Confirmed alignment on the main mounts.
The fully assembled Sukhoi taxis out, showcasing the integration of the thrust vectoring nozzle assembly. Accelerate.
The Process A mechanical assembly articulates precisely under extreme stress, showcasing flawless integration with the
Executing sharp pitch command now. As confirmed by the HUD, the nozzles are deflecting immediately. The FCS integration is seamless.
How are the refractory segments looking?
Clear. And the data dump confirms full operational spec.
Integrated and mission ready. The Su-30MKK's thrust vectoring nozzles are the culmination of advanced robotic manufacturing.
The Sukhoi Su-30MKK accelerates into the night sky. The metallic nozzles articulate slightly during the climb.